Hello and welcome to Mr. Taufik's Maths and Econs channel. Today we are going through advanced factors, multiples, and prime roots. Whoa, this is going to be huge. And guess what? These questions, the questions in this topic area are so important. Like, you cannot miss them, right? You cannot afford to miss them. And that's why we will be doing this together. I hope you're ready. If you are ready for this, you're ready to learn, you're ready to go advance. Can I hear you say advance? Yeah, okay, good. All right, without wasting further time, this is Lagos State BECE Maths, and we're going through factors, multiples, and prime roots. Advanced version, actually, not the basic one, to prepare you for like advanced, score, okay, and grade in your exams. All right, question number one. Question says, find the smallest whole number by which 360 must be multiplied to make it a perfect square. So anytime you see a question like this and you want to like find the smallest number to multiply by a number to make it a perfect square, all you have to do is just to do the repeated division. Okay, so 360, what is the smallest prime number that can divide 360? That is 2. That's going to give us 180. Another 2, that's going to give us 90. Then 90 divided by 2, that's going to give us 45. 45 divided by 2 is not possible. So can 3 divide 45? The quickest way to check if 3 can divide the number is just to add these two numbers together. So 4 and 5, 4 plus 5 is basically 9. Is 9 a multiple of 3? Yes, 3 times 3 is 9. So that means 3 can divide. So 45 divided by 3, 3 in 4, 1. Remainder 1. 3 in 15 is 5. Then can 3 still divide? Yes, 3 can still divide because 3 times 5 is 15. This is going to be 5, 5, and this is going to be 1. Now, what do? So, to find that number that you need to multiply this to make it a perfect square, all the prime factors will be grouped into 2's. So, we group this into 2, we group them into 2's. Now, there is no extra 2 left, so we're going to leave this alone for now. We'll group this into 2, and there is no what? There is no extra 5 left. So, to make it a perfect square, all the prime factor must be grouped in 2's. So, that means that these 2, we still need to multiply this by an extra 2, and we need to multiply also 5 by an extra 5, so that they are all in 2's. Are we together? So, all you now have to do now is now take those numbers, those extra numbers that you have multiplied, okay, by the factors. So those are the two numbers that you will multiply together. So 2 times 5, that gives us 10. So that simply means 10 is the smallest number that we need to multiply by 360 to make it a perfect square. So our answer is C. And if you think about it, if you multiply 360 by 10, what does it give you? It gives you 3,600. So what is the square root of 3,600? 3,600 is just 36 times 100. So square root of 36 is 6, and square root of 100 is 10, and that gives us 60. So that's it, you see? So 3,600 is a perfect square, but 360 is not a perfect square. So to now make 360 become a perfect square, you need to multiply by 10. And that's essentially what we have done. Good job, everybody. Now let's go on to question number 2. So question number 2 says, I'm just going to clean that up. So question number 2 says, express 1,260 completely as a product of its prime factors in index form. Okay, so this is a question that you must know how to do. You need to know how to do it. Are we together? So it's still the same thing. Repeated division is basically the most fundamental tactics in dealing with many of these questions. So 1260, what is the smallest prime factor that can divide this? Anytime I see 0, I know 2 can divide, right? So 2 in 1, impossible. 2 in 12, that is 6. 2 in 6, that is 3. And 2 in 0, that remains 0. Again, 2 in 6, that gives you 3. 2 in 3, 1, remainder 1. And then that will be 5. I need to quickly check, can 3 go? So 3, 1, 5. To check if 3 can divide 3, 1, 5, just add the numbers together. 3 plus 1 plus 5, that gives us 9. 9 is a multiple of 3, so that means 3 can go. Woo, okay, let's do this. So 3, 1, 5 divided by 3. 3 in 3, 1. 3 in 1, 0, right? And you must write that 0. Some of you, a particular mistake students make here is that 0 here, they didn't tend to write it, and that becomes a problem, right? So, so 3 in 3, 1. 3 in 1 in the middle there, 0. Then add that 1 to what? To 5 to become 15. So 3 in 15, 5. Can 3 still go? 1 plus 0 plus 5. That's 6. Yes, 3 can still go. So 3 here. 3 in 10, that's 3 remainder 1. And 3 in 15, that is 5. I don't think 3 can go anymore. So now 5 should be able to go because 5 times 7 is 35. So that's 7. And then 7 can go, and that gives us 1. Okay? So expressing the number as a product of the prime factor, all you have to do is just multiply all these numbers together. So we have 2 times 2 times 3 times 3 times 5 times 7. Now, writing them in index form just means as a power of something. So how many 2's do we have? 2 times 2 in 2 places. That's going to be 2 to the power of 2. 3 times 3 in how many places? Again, in 2 places, that's going to become times 3 to the power of 2. Then only 1 5 times 5, and then only 1 7. So what option is that? Option A. Okay, that's good. I mean, we're making huge, fantastic progress. Okay, question number 3. What? This looks completely strange from what a lot of you have seen. But guess what? It's super simple, and you need to know this as well. You need to know this. So find the HCF and LCM of A, which is 2 to the power of 3 times 3 to the power of 2 times 5, and then B, which is 2 to the power of 2 times 3 to the power of 4 times 7 to the power of 1. So what a lot of you will tend to do here is to multiply the number first and now start to work out HCF and LCM. And then the question even says leave your answer in index form. So doing that is a huge waste of time. You don't need to do that. So what do you need to do instead? Yes, I'll show you, and that's why Mr. Taufik is here with you today. So let's write out the numbers again to make perfect sense. So A is going to be 2 to the power of 3 times 3 to the power of 2 times 5. And then B, we have 2 to the power of 2 times 3 to the power of 4, and then times 7. You see, when they say the LCM, okay, you just have to look at the index numbers, right? The LCM is basically, you're looking at the highest power. the highest power. So remember, LCM is what? The highest power. Highest power. So when you're looking for the LCM, you're looking for the highest power of the prime factors. So if you compare this to 2 to the power of 3 and 2 to the power of 3, which one has the highest power? 2 to the power of 3. Easy. Times, compare the next one, 3 to the power of 4 and 3 to the power of 2, 3 to the power of 4. Compare the next one. So the highest power is 5 to the power of 1 because there's only 5 there, so you have to write it. And then also there's only 1 7, so which is this, we also have to write it. And that's our answer, right? So for LCM, when you have your numbers and index funds like this, if a particular number only appears in one of the numbers, maybe 5 only appears in A, doesn't appear in B, so you have to write it, okay? And if any prime factor appears in only one of them, you just have to write it, okay? And that's your answer. That's your answer. That is all you have to do. Now the HCF, So the HCF on the other side, you're looking at the lowest. You're looking at the lowest. And whatever doesn't appear in both of them, you don't consider it at all for the HCF, okay? For the HCF, you're looking at the lowest power. Okay, and whatever does not appear in both of them, you don't write it. So let's start by looking at 2 to the power of 3, 2 to the power of 2. Which one are we going to pick, guys? Which one? Yes, 2 to the power of 2. Your brains are working. Good job, everybody. Times. Next one, guys. Which one are we going to pick? 3 to the power of 2 or 3 to the power of 4? HCF. 3 to the power of 4? No, this is not LCM. This is HCF. You have to choose the one with the lowest power. Remember. Yeah, exactly. So the answer is 3 to the power of 2. Somebody said times 5. Why? Why is it supposed to be times 5? Remember, if it's HCF, if it's not common, if that prime factor is not common to both of them, then we're not going to choose it. We're not going to use it. 5 is only common to this. It's not common to B. It's not going to be there. And 7 is only common to this. It's not common to, it's not going to be there. It's not going to be in the HCF. HCF the lowest. The only things that are common to both of them. But LCM, you're looking for the highest power. So the answer is what we have over there. So this is our precious answer gotten by Mr. Taufik and team, right? We are a team, isn't it? So basically, which option satisfies this? Is it A? It's looking like it's A. Yeah, it's A. Yes, the answer is A. Good job, guys. We did this. Woohoo! Okay, guess what, guys? In fact, I think this particular topic even has more than 3 multiple choice. Wow, this means this topic is very important, right? So for you to have more than 3 multiple choice, it means it just shows the importance of that topic for everybody to know how to do it and how to do it very well. So that being said, question number 4. Okay, this question says, let X be the LCM of 12 and 15, and let Y be their HCF. Evaluate the value of 3x minus 4y. Wow, this is beautiful. So we need to find 3x minus 4y. But then X is the LCM of 12 and 15. And then Y is what? The HCF of, again, 12 and 15. Some of you were confused, but now you'll be like, oh, I can do this. It's easy. Yeah, I know you can do it because Mr. Taufik has explained a bit of it, right? Okay, so we need to find the LCM of these two numbers, right? To find the LCM, you have to draw, again, your table. We've got 12, we've got 15. By just looking at these two numbers, I think the LCM is 60, but let's do it together. Let's not get ahead of ourselves. So 2 can go in 12, so that's going to be 6. We'll leave these like that. 2 can still go in 6. 3, 15, then 3, 1, 5, and then 5, 1, 1. So anytime I'm trying to find the LCM, I just multiply backwards. I don't do 2 times 2 times 3 times 5 because it gets harder as the number gets bigger. Rather, I go the other way. So 5 times 3, 15. Then 15 times 2, 30. And 30 times 2, 60. You can see, life is easy. So our LCM is basically 60, right? So LCM, which is X, which is the LCM, 60. Now let's find the HCF. The HCF of this same number. So we draw another table. And this is my favorite way of finding HCF, okay? So we have the same thing, 12 and 15. But because it's the HCF, so this is the LCM, don't forget. Because it's the HCF, okay, we only divide up to the point where, like, you only focus on a number, a prime factor that can divide both of them. So if I say 2, 2 cannot divide both of them. So I'm not going to use 2. Then 3 can divide both of them. So 3 can go here. And this is going to be 4. And this is going to be 5. Can any other number go here? No, the only number that can go here is 1, right? And basically makes no difference. So therefore, our HCF is 3 times 1, which is just 3. HCF is 3. So that is our Y. So that means X is equal to 60. And then Y is equal to 3. So therefore, the question says we should find 3x minus 4y. So 3x minus 4y, because x is 60, that becomes 3 times 60 minus 4 times y, which is 3. So 3 times 60, 3 times 6, 18, add your 0, that's 180. Take away 4 times 3, which is 12. And that must give us 180 minus 10, 170, 170 minus 2, 168, 168. And that is the answer. Option A. Okay, guys, is that all for these? Do we have theory questions? Whoa, we got theory questions. This topic must be very interesting. I believe you're all enjoying this right now. Theory says, evaluate the square root of the following large numbers. Right, the first one is square root of 44,100. Some people will be like, so what? But this is not a calculator question. How on earth do you expect us to do this? So this one is 44,100. Now, 44,100 is the same thing. Like I said earlier, you just basically think about breaking it into 2 parts, whereby one is going to be like 100 and the other one is going to be like a. So 441 times 100 is the same thing as 44,100. All you have to now do is you just have to find the square root of 441 times the square root of 100. Everybody knows the square root of 100 is 10, right? Everybody knows the square root of 100 is essentially 10 times, but not everybody knows the square root of 441. But I'll tell you for free, the square root is 21. As easy as that. So 21 times 10, 210. And that's our answer. So how do I know that is 10? And that's why you need to memorize your squared numbers, to be very honest. So you need to know your squared numbers. But should in case you are stuck in an exam, you don't know what the square root is supposed to be, you just basically come and start dividing. Can 2 go here? No, 2 cannot go. Can 3 go? Let's check. 4 plus 4 plus 1. That's 9. Yes, 3 can go. So 3 here. 3 in 4, 1 with a remainder of 1. 3 in 14. That's going to be 3 times 4, 12. That's going to be 4 with a remainder of 2. 3 in 21, 7. Can 3 still go? 1 plus 4 plus 7. 1 plus 4, 5. 5 plus 7, 12. Yes, 3 can still go because 12 is a multiple of 3. So 3 here. 3 in 1, impossible. 3 in 14. That's 4 remainder 2. 3 in 27. That must be 9. 7 in 49, 7. 7 here, 1. Group them in 2s, but because we're trying to find the square root, we group them in 2s. Are we together? We group them in 2s. So we group them in 2s. So 3 can be grouped into, like, you group them in 2s basically. So that's just 1, 3. And then this is 1, 7. So you just multiply these two together. And that's going to be 3 times 7, which is 21. So the square root of 441 is 21. As you can see, as we have solved already, it's 21. And then the square root of 100 is 10. And then you got your answer. Yeah, that is the part I. Just the part I. And we already spent so much. We already used up so much space. Now, the second one is I. I find the square root of 5625. 5625. Square root of 5625. So we just have to follow the same step we followed earlier. Okay, just gonna manage out the space. So to do this, you have to just do your repeated division. That's all, because nobody's expected to memorize square root of a number as large as this. So 5625. Can 3 go? I know 2 cannot go because it ends with 5. Can 3 go? So we're gonna add 5 plus 6 plus 2 plus 5. 5 plus 6 is 11. 11 plus 2 is 13. 13 plus 5 is 18. Yes, 3 times 6 is 18. So 3 can go. 3 in 5 is 1, with a remainder of 2. 3 in 26. So the 3 times 8 is 24. So that means it's going to go 8 times in 26. So that's 24. And to get to 26, we have 2 numbers left. So with a remainder of 2. So in 22, 3 in 22, that's going to be 3 times 7, 21. So that's 7 times with the remainder of 1. And in 15, that is 5. Can 3 still go? Well, let's check. 1 plus 8 plus 7 plus 5. 1 plus 8, 9. 9 plus 7, 16. 16 plus 5, 21. Yes, 3 can still go. 3 in 1, impossible. 3 in 18. That must be 6. 3 in 7, 2 remainder 1, and 3 in 15, 5. 6, 25. Can 3 still go? 6 plus 2 plus 5. 6 plus 2, 8. 8 plus 5, 13. So it's cannot go. Then the next number should be 5. Next prime factor should be 5. Somebody can say, why are you not using 4? Because 4 cannot go. And 4 is not even a prime factor. We have to use a prime factor. A prime number that is a factor, basically. So 5 in 6, 1, with a remainder of 1. 5 in 12. So that's going to be 2 with a remainder of 2. And 5 in 25, that's 5. 5 can still go. 5 in 12, 2 with a remainder of 2. 5 in 25, 5. Oh, 5 again, 5, and then 5 again, 1. So the square root, you group them in 2s. This is 3, this is 5, and then this is 5. Multiply these 3 numbers out. Okay, multiply those 3 numbers out. So we have 3 times 5 times 5. 5 times 5, 25. 25 times 3, 75. And that's our answer. So the square root of 565 is 75. So, okay, theory question number 6 says, simplify the terms inside the radical first and evaluate the square root of the mixed number. Okay, easy. So you should be able to find square root of fractions and codes. Something you must know how to do. So the very first thing you need to do is you need to rewrite the numbers as improper fractions. So the first one is going to be 12 times 5, which is 60. 60 plus 4, which is 64. So that gives us 64 divided by 12. Take out the next one, which is going to be 3 times 1, 3, plus 1, that's 4. That's going to be 4 divided by 3. Now, because I want to add these two fractions, I want the denominators to the same. So I've got to multiply these by 4 and multiply these by 4 as well. And then that gives us what? So therefore, we have 64 divided by 12. Take away 4 times 4 in the numerator, that's 16. And 3 times 4 in the denominator, that's going to be 12. And therefore, we're going to have 64. So the denominator is going to become 1 because they are the same. Just write the denominator and take away the numerator. So we're going to have a denominator of 12. And then the numerator is 64, take away 16. We have to borrow 1 from this. This becomes 5. This becomes 1. 14 minus 6. That will be 8, I believe. Right. I believe that's going to be 8. 14, yeah. Minus 6. Yeah, that should be 8. And then 5 minus 1, that's 4. So that's going to be 48. So now we don't know the square root of these two numbers. So we can reduce them. How can we reduce them? We reduce them in such a way that the numbers will become perfect squares. For example, now, if I divide 12 by 3, it becomes what? 4. Right? So you have to do the same thing here. Divide 48 by 3 as well. So 48 divided by 3. 3 in 4, that is 1. With a remainder of 1. 3 in 18, that's 6. So that becomes, the numerator becomes 16. The denominator becomes 4 after reducing them by 3. So we have 6 square root of 16 divided by 4. In fact, I should have just done 48 divided by 12. So 4 times 4 is 16. So 4 here 1, 4 here, that is 4. So the number left is just what? The number left is just 4. So square root of 4 is 2. Our answer is 2. You can see the question looks scary, but if you follow these simple steps, you see that you have your answer, and it's pretty easy. Wow, the last question. Woo! This question says find the HCF and the LCM of the following set of fractions. Okay, so for this one, you need to use a particular formula. So, and the formula is that if I'm looking for the HCF of fractions, the formula is HCF of numerator divided by the LCM of the denominator. And then if you're looking for the LCM of fractions, you're going to do the LCM of the numerator divided by HCF rather of denominator. And that's all. Very easy. Very, very easy. That's what you need to do. That's what you need to know. You need to know the formula. So if I'm looking for the HCF, my HCF of the numerator is going to stay in the numerator. Like anything you're looking for is going to be in the numerator on the formula. If you're looking for HCF, it stays in the numerator. If you're looking for LCM, it stays in the numerator. So to find the HCF, we're going to have to do the HCF of the numerator. So HCF of the numerator. Okay, I think I'll have to work that out. I need more space here. Okay, so the numerator is 2, 4, and what? And 6. So I want to find the HCF. So HCF just means finding one number, finding all the factors that can divide everything. So 2 here, 1, 2, and 3. And if you look at these numbers, no number can divide them anymore. No number can divide them anymore. No single number can divide them anymore. So these are our highest common factor. So HCF of the numerator is 2. Then so this is HCF of what? The numerator. Okay. So I think I'll just bring this down here. I'll bring it out here. Yes. I think it's better here. So HCF of the numerator is 2. Then if you look at the formula for the HCF, I'm trying to find the HCF. This is what I'm trying to do now. So I found the HCF of the numerator. Now let me find the LCM of the denominator. So LCM of denominator. So it's still so the denominators now are what? Look at the denominators. They are 3, 5, 7. The 2, 4, 6 are the numerator of each of the fractions. So 3, 5, 7. 3, 5, 7. We want to get the LCM. So move down a little bit. So the smallest prime factor here is 3. 3 in 3, 1. 3 in 5, 5, 7. Then 5, 1, 1, 7, and then 7. 7 times 5, 35. And 35 times 3, that seems to be 105. So LCM is 105. So now that we know that, that means our HCF of the fraction is going to be HCF of the numerator, which is 2, divided by LCM of the denominator, and that is basically 105. So this is the answer to the HCF of the fraction. Now let's go to the LCM. So for the LCM of the fraction, we need to find the LCM of the numerator. And if you look at the numerator, the numerators are 2, 4, and 6. So 2 here, 2 in 2, 1, 2 in 4, 2, 2 in that 3. 2 again, 1, 1, 3, and then 3, 1, 1, 1. So therefore, our LCM is going to be 3 times 2, 6, and 6 times 2, 12. So LCM is 12. So LCM of the numerator is 12 divided by HCF of the denominator. And what are the denominator? The denominators are 3, 5, and 7. So 3, 5, 7. We want to find the HCF of these numbers. And the way I'm looking at it, it doesn't seem like there's anything that can go except 1. So there's no single number that can divide any of this. We just need the number. We just need the factors that can divide all these numbers at once. So the only number that can do that is 1. So the HCF of the denominator is 1. So therefore, this is 12 over 1, and the answer is 12. So this is the LCM of the fraction, and this is the HCF of fraction. So you just need to remember this formula, okay? Once you do that, you'll be able to solve these questions easily. And that's it for today. Now it's your turn. Okay, so we've gotten to your turn now to answer the question. So remember, the first 5 people to submit to get your answers marked, especially by Mr. Taufik. So these are the questions. This is up to question 3 for the multiple choice. I'm just going to go down a little bit. And yeah, up to theory question 4, as you can see, multiple choice question 4, then theory question 5, theory question 6, and theory question 7. All right, so I wish you the very best. Keep practicing and make sure you go for excellence. And I'll see you in the next video. Bye-bye.